Bing, 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 bing. Bing, 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 bing. Oh, shit. Organizing change 610. Wowee. That sounds like fun. Insta got hacked. Next semester email set up tutoring. Dang, that's crazy. Organizing change 610. Wowee. Who are you? Have you tutored with me before? That sounds like fun. Hold on one second. I'm trying to get this pop out chat link here. Insta got hacked. Next semester email set up tutoring. Orders, dang, that's crazy. Organizing change 610. Right. Wowee. Who are you? Have you tutored with me before? That sounds like fun. Hold on one second. I'm trying to get this pop out chat link here. Insta got hacked. Next semester email set up tutoring. Orders, dang, that's crazy. Okay. I think organizing change 610. Shadow. Wow. Hey, who are you? Have you tutored with me before? See you. Sounds like fun. Hold on one second. That's great. I don't know how the end of your... Okay, we got to get rid of this streamception here. I don't know how the end of your semester went. And I'm wondering how it went. Yeah. Because I think I missed one of our sessions because I was going through a crazy time. And then I think your semester was just pretty much over at that point. So I'm sorry about that. 92, let's go. In Calc, that's big news. Calc is short for calculator, by the way. What am I going to do? Set up a goal. So I just got back from a parkour training session in which I did 100 push-ups and 50 pull-ups in 9 minutes, which is a little bit worse than my time from a few days ago, which was 8 minutes. But that being said, I'm still willing to set up a super chat goal consisting of many push-ups because I'm trying to push myself here. So, and it probably won't get done, which is fine. So I'll just, be the big man and say, oh, I'm going to do so many push-ups. So I'll do 30 super chats of 2 or higher. And then 60 push-ups as a result. Bet. You're not ready for physics. You are ready for physics. You really like grasped calculus. I want to make that clear. It was very impressive. Yeah. Let's see here. So yeah, I'm happy. I'm ready. Excited to help you with physics. It's gonna be great. Okay. I think that we're going to keep going here. So if you weren't here earlier, we've been working on basically redesigning the web from scratch based on what we've learned to try to make it sleeker, thinner, more comfortable, easier to use, all these things. Because before, I had this design that is kind of old school and outdated when you take it with all the other things that I've learned since I first made that design. And those other things just don't fit anymore. So for instance, like adding this extra little bump here so that I could fit the trigger slot through. Now we've got the trigger slot pre-baked into the shape of it so that we can sort of design around it from the outset instead of trying to tack it on later. And this will culminate in a new pressure vessel design that is sleeker. We can hold more fluid than ever before. You can see we're elongating this a little bit, but all the mechanisms are also going to be hidden so it doesn't look crappy. And yeah, that's pretty much where we're at today. So I hope everybody's ready for what's to come. So where I was before is I got the hinge working here. And I think it's going to basically be this shape, and the angle that we're able to move it to is 67 degrees, and that's a complete coincidence, by the way. Complete coincidence. Funny you're talking about aerial flip 610. I was just talking to like my parkour buddies, and we were talking about aerial flips. And I have like more, I guess you'd say, like gymnastics experience than the rest of the parkour guys. So I come at things from a little bit different place. But they were talking about aerial flips, which of course is the classic gymnastics move. And they were like, it's crazy how like female gymnasts find like an aerial flip so easy and standing back flip is more difficult. And I think that's a little bit misguided because I think both are easy to them. But the thing with the aerial flip, like if you're just comparing one skill, right? Aerial flip versus um, like back tuck or if you're just comparing the aerial flip like men versus women, right? Women are generally more flexible, and what that means, well, I'm sorry, I'm trying to turn off the preview on enable preview. There we go. Okay, we don't need the preview on the OBS. Okay, so women are more flexible. And so the thing is, like, if you're doing an aerial flip, flexibility is really helpful because it all comes from just like a cartwheel, that leg going up behind your head, over your head to the other side. This time, instead of a cartwheel, you're not putting your hands on the ground. So it helps a lot when your leg is already halfway around to reach the other side before you even left the ground with your leg that's doing the jumping. That's how I've imagined it, and I've never been able to do it. It's probably how I would coach it, but I think flexibility is a great help for that sort of thing. So definitely stretch a lot. Try to get your middle splits or your front splits or whatever. No, Henry, I don't really make my own PCBs on a CNC. I could do it if I was in a pinch, but the fact is, like, PCB way is cheap, it's easy, and if you're just doing the PCBs especially and not the components, there's really no reason to do it because it's like dirt cheap and it takes like just a few days to arrive. So there's really no reason to do the PCBs in-house because that's just like an extremely accessible service at this point. And it's not even like this stream is not sponsored by PCBWay, by the way, but like that is certainly my chosen service. And I've used some of the other ones, I will say, and I still think that PCBWay is like a lot easier. Just I think they have like engineers like that are really capable to look at your project and your design files. And they will kind of spot where you made a mistake. And I think that is pretty helpful. All right. So enough chitter chatter, enough jibber jabber. I'm in the middle of designing an adjustable bracelet. I'm not worrying about anything else at this moment. That's it. So given that, and then hopefully I'll be able to print it, because this only has an hour and 39 minutes left. So we basically have an hour and 39 minutes to get this done, and then we can print the prototype in PLA. see how it fits. I think that would be really cool. Let's see here. Let's move this back, 67. Okay. So. I sort of have to think about what is the range of motion here. You can see I've got a bunch of sketches here. Hey, how about that? Another scholarship. Congratulations. That's fantastic. I am super happy for you. That is huge. It's like that's so huge. Crazy like world of difference that can make. I'm extremely pleased to hear that. That's awesome. I don't have any Bamboo Lab printers. I have a Prusa and I have an Anycubic, and that's it for FDM at the moment. Damn, 610, that can happen. That's why you're organizing change. Oh, man. Okay, so this is for little bitty wrists here. And this tells me that if I want to move the circuit board, which should move with everything else, it's going to stick out here. I hate that, actually. That's like not chill, like at all. Let me move backwards. I want to think here, because if this is considered the like neutral position, this is like what's going to fit my arm, my wrist, then we're going to need some bigger wrists and some smaller wrists. In that case, if we go here, like bigger, let's say maybe 5 millimeters bigger. And let's call it you do really need it. There's some tiny girls out there. Holy shit, dude. Dude. Shadow. Thank you, my man. Holy cow. You're right, it absolutely does count. And I got to do those push-ups now. Holy moly. That is super generous. Okay. You got me. Everyone thanks Shadow for doing the most. Wow. That definitely counts. Okay. Forget that. Wow. Okay. Here we go. Now keep in mind, I've already done 100 today. I'm going to put the mic on the floor next to my head. And I hope you guys can see this. It's not the best. I know that my camera is weird. And trust me, that's not my fault. Get the lighting over here. Okay, there's the floor. Easy way out, that is true. Okay. I think you guys can see me. Yeah, this is pretty visible. 60 push-ups. Okay, I did 100 earlier, but not like all in a row. So I might still have some stamina. Maybe I'm even like warmed up. If I can't do these all in a row, please don't blame me. I'm gonna do 60 though. I'm gonna try to do them all in a row. Okay. Here we go, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 1, 2, 3, 4, 5, 6, 7, 9, 20. 1, 2, 7, 8, 30. Goodness me. 1, 2, 3, 5, 6, 7, 8, 9, 10. It's 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 50. 1, 2, 3, 4, 5. Come on, 5 more. 6, 7, 8, 9. 60. Oh, guys. Oh, you did this to me, Shadow. My goodness. Whew. Good Lord. Whew. That was fun. Thank you so much. Gonna make sure to join a late night stream when you're already tired to just drop 120. Whew. All right. Oh. Okay. That means we got to set up level 2. Thank you so much, Shadow. That is extremely generous. Extremely generous. It also makes 160 push-ups total for today. That's probably the most I've ever done in my life in one day. That's crazy. Okay. Goodness. Whew. That was fun. Okay. I'm gonna see here. We gotta set up level 2. Like, and I don't, like, $60 for one stream is insane, especially from one guy. Thank you so much. So next time going to be a lot easier. 10 super chats, $2 each, and we're going to go 20 dips. Going to be very chill. The amazing ASMR. Is that ASMR, the sound of me grunting, doing push-ups? Oh my goodness. I need to grab some water. That's pretty rough. I've been doing a lot of ASMR lately. What other ASMR have I been doing? Ugh. Oh, maybe it's slurping. I love to slurp my coffee, and that's probably what I was doing in this morning stream. Yeah. Okay. All right, let's see here. Music, the sound of 30 parts coming out of the window. That's true. Last night I was composing music. Oh my god, where was I? Okay, so tiny wrists. I think that like my wrist is pretty thin, but my girlfriend's wrist is a lot thinner. So I'm trying to think here. I think 10 millimeters down has to be more than enough. You know, this might be an ambitious adjustment because the last version, I'm still a little bit out of breath. The last version I did was like I thought it was super adjustable, and then I tried it. My girlfriend tried it, and it was still a little bit loose on her wrist, and I was like, Jesus Christ. I thought I measured it too. So I think like going over is probably good because there are people with really skinny arms out there that might need to use this. So yeah. So the other thing is this having this like tight thing here kind of sucks. I'm almost wondering. So we got 5 up, 10 down from the neutral position. That's easy to remember. 5 up, 10 down. About using HHO projects because there is a lot of potential. What is HHO projects? Oh, of course. So HHO. Yeah, I think that like. I think it's been proven that this is not a good idea for electric vehicles, or for rather like hydrogen. I guess it would be like hydrogen-powered combustion engines, right? I don't think that. I think it's pretty good consensus. Hey, Shadow, come on, man. Just because you got this scholarship, you can't be just chucking this money at me, man. But I appreciate it very much. It's gonna help a lot. And this does count towards the goal, by the way, towards the 20 dips. That's very sweet that you would say that. That's very generous. I think it does count towards the goal. So that means $5 more until I have to do 20 dips. Oh my goodness. Okay. Shadow is making me work. I'm getting sweaty too. Oof. Luckily my AC is on. I need to turn it up. Oh, I gotta move this one back too. 10. Hey man. I don't think that's true. You had it in you. The calculus. I could tell. Like all that I do as a good tutor, like I'm gonna give myself some credit. I think I'm a pretty good tutor. All that I do is give you, like a little push. And it's important to me, to not just be like, hey, this is how you do calculus. It's about, putting your mind in a state where calculus becomes a lot easier. So even problems that you haven't seen before, you get an intuition for them. At least that's what I try to accomplish. I feel like that's something that we can all benefit from. And the people who did that for me when I was your age, I have like great, great gratitude for. So what I'm thinking here is that I need to get a little sliver of this to act almost as a little cushion. Oh my god, I'm sweating. You cleared my head on how to model Simulink blocks by just looking at equations and how robot manipulation is mapped to Jacobian. That's one of the things that that I helped 610 with, and it was a lot of fun. And yeah, I'm glad that I could help you with that, dude. That's like, and it's cool stuff too, especially Simulink. Like, and that's Simulink is one thing that I remember from, from my. I think we first did it in my junior year, like signals and systems and like introductory controls, like yeah, modeling Simulink blocks, modeling systems with Simulink. And I remember being in those classes and be like, oh my gosh, like something clicked. And then it's like you get it, and any problem someone can throw at you, you can model in Simulink. Almost any problem. That came to an issue when I started to have to deal with like multidimensional partial differential equation systems, like you get with fluid dynamics, and that's like suddenly Simulink doesn't play much of a role anymore. But I was still able to use MATLAB to write some solvers for these partial differential equation systems. All right, let me show you guys what I'm thinking here. So that's there. And then this cut with that, keep the tools. All right, and now watch what happens now as we move this down, this shape. Oh, I guess that cuts through there. But you see how this is kind of like filling in that space there? Okay, so I think, what can I do here? I'm going to need to sacrifice some of it, some of that shape that I just made. Y'all, I might have to put a t-shirt on. This is crazy. I just got out of the shower, too. Oh. I think this one works. That's much better. All right, let's see here. Oh. So, let's go back to the sketch. We've got to, like, basically draw another line here. And this will be parallel to that. And then we alter this one. Now that fits now, that can slide past, but we have the issue where it's made out of like sharp, like there's a little sharp part. And so we'll add a fillet, and then maybe this whole thing was for nothing. I don't know. You see that? So that keeps the shape of the wrist a little bit. There's going to be a gap here. So hopefully no pinching. I don't think there will be any pinching. There shouldn't be anyway. And I'm going to fillet that one pretty generously. 1. Is that too big? It's a little big. 0.7? 0.7 I'll do. It's pretty generous, but I think that's what I need to do to prevent the pinching. So that compresses the top of the wrist there. So the problem is, like, for really skinny people, this is going to have like a part poking out here. But no one's going to be this skinny, surely, right? So it's going to be like here. And then that's not too bad. And then maybe I will chamfer this so it doesn't seem so crazy, you know? But that will come later, because we also do need like, this is the motor compartment here. So we're actually going to need like a decent amount of space. I don't like doing the details right now, but what did I just do? So I'm going to make this one go backwards by 19. No, backwards. 19 plus 0.8. Thinnest wall thickness there. We'll probably need a little bit more than that. But maybe not. Okay, I'm going to take this motor now. Make a copy. And I'm going to move it until it gets to where it needs to be. Like, let's say here. It's pretty well hidden. Yeah, that's the other thing that I'm doing with this, is the motor being embedded instead of exposed. So I think, like, that's pretty decent. Yeah, I'm a big fan of that. Does it interfere with anything over here? Not really. Yeah. So if we make this motor go here, I want a specific number, not just a random place. So let's just say, because I don't need to actually put the motor in right now, I can keep that separate. I just, like, this wall right here, make it bigger by like a millimeter or something like that. So the camera's funky. It's originally green. So in OBS, I made it look less offensive and just kind of gave it a sepia. And there's these lines going across it as well. That comes from my webcam software. I don't know what's going on, but it comes from my webcam software. I think there's like a driver incompatibility, because I've done some janky kind of jailbreaky updates on my computer, which have led some things to break. And I think that this is one of them. So we're just going to have to live with it. But I'm like black and white. So it's kind of like Spider Noir, you know what I mean? It's good, like, you know, with the times, kind of, you know, like a nice contemporary activity to have a black and white camera. So this is now 2 millimeters. Unfortunately, I think that we might need 2 more millimeters. Can we get away with that? It looks like we can. It looks like we totally can. So let's keep that. Because this will probably have a nice little counter bore. 6.5 millimeter counter bore. That will go down 3. And our hinge screw, maybe 2.5 is enough. And our hinge screw will be poking towards that. And how wide is this actually? Oh, perfect. Holy cow. I could not have asked for a better... Actually, it's not perfect. It's nearly perfect. But it's not the worst thing in the world. I think I have fasteners that can make this work. And what about this one? This is 3. I want to point out that this hinge is pretty overkill. But if I take this one, I need to move it back by 1 just to make this symmetrical for the prototype. And this one and this one, and move it forward by 1. Then we can have the same setup on the other side with a 6.5 millimeter wide, 2.5 millimeter deep counterbore. Booyah. What happened to Blood Spider and Friends? Blood Spider is still kicking, man. He did like a podcast episode. Remember? And then he was going to put me on it, but I think he forgot. So I don't know what is going on there. But I think he forgot. Um, 0.5. 2.5. Yeah. Okay, so we got space for our hinge screw here. Good, good, good. That's important. The next thing is that we actually kind of have to have the motor compartment rigidly attached to all the moving parts. Not doing push-ups at night, that's what he's not doing. That's funny. Yeah, he's still working on his fan film. He's super passionate about it. And I mean, it looks like it's going to go well. I mean, it's just like we need more of that stuff in the world, you know, people being really passionate about what they're working on. Okay. So my contention is that we need to recreate this slot. And then here's kind of what I feel like doing here. Let's take this one. We take that. It's already there. We take this. Okay. So that's all going to be part of it. Da-da-da-da-da-da. But then, because these are going to have to slide past each other, I want to find something here. Okay, we're going to just construction line all of this. I got to remember to do that. It's much better practice to have your guides all be construction lines and then make the outline after you know what the shape is going to be. Okay, coincided there. Okay, so it's all coming together now. The only question is, get this out of the way. It's old news. If I were to get this and this and this, okay, maybe I'll trim this one. So if I were to get this and this and this, and this, and I were to copy it, paste it, and then rotate that shape around this circle, what do I get? Does it interfere? It looks like it will interfere because it's crossing itself, this line. Mm-hmm. Okay. Now, why is this a problem? It's a problem because I'm not doing this right. I remember the podcast I had with Knight. Yeah. Those were good times. Those were young times. You know what I mean? I suck at working with people. I wish I didn't. I was just talking about this to a friend. But like, God, sometimes I don't know how to handle it. I would love to, I mean, part of it is resources, right? To be able to collaborate with people, you need to be able to sacrifice a little bit more. Because you're sacrificing for each other, essentially. And it's hard to do, you know. Oh no, we only have 4 minutes left. 4 minutes left on the 20 div goal. Oh no. It's not a big deal, guys. shadow spider really came through, so we don't really have to worry about it. All right, here's what I'm going to do here. First things first. Unconstruction this, unconstruction this, and unconstruction this, and unconstruction this, unconstruction this, and unconstruction that, and that. And suddenly, I have a shape. I don't necessarily need that shape to be totally flat. In fact, I kind of think that doesn't look and feel very good. So we're going to keep the chamfers and just extend them. One here. And that's it. Just that shape. We're going to go there. It's going to be a new body. And then we're going to combine the bodies. But wait a minute. But then that kind of limits the adjustability of it, constraining this to be a flat surface here, when really you just need these things to slide past each other, but also be able to rotate. It's like a knee joint, right? The knee is a really interesting joint. Oh my God. Like a frying ketchup. Get out of here. My girlfriend would love that one. She loves ketchup on her fries. Okay. 20 dips. You really came back just to make this happen. I'm dead. Okay, everyone give a round of applause for Mr. Shadow Spider here, donating a whopping $80 to a single stream. My guy, come on. You're one of my most prized customers. You pay me in exchange for goods and services, not for this circus act. Okay. Here we go. Oh God, I'm so dead. 160 push-ups and I still have to do 20 dips. This is nuts. Okay, I'm gonna try to do it without stopping. I can feel my arms being so weak. God, okay, I'm up. 1, 2, 3, 4, 5, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ugh. And this is service. Oh, you bet your ass it is. It's entertainment. Okay, no more goals. No more goals. No more goals. Get out of here. Ugh. Cool, man. Good. Wow. Who knew streaming was so good for your physical health? Holy moly. this this one here. Instead, I think what I want is no matter what. Maybe I should draw this first. Okay. Should draw this first. Right here. Right now. First things first, this part doesn't slide. Hey, congratulations. 610 on finishing another shift. That is big news. It's not easy. What I missed here? This is part of the fillet. So if I just do a tangent arc, and then make it also tangent with this, and it's fully defined. That's the shape that I'm missing. And that's where the motor goes. So this shape is what we're trying to recover here, part of the bracelet where the motor will sit. Go here, new body. And then we will combine this and that. So now what we have, which is kind of wild, actually. That's 16 millimeters. It would be nice to have a little bit of a pad down here, but I'll ignore that for now because there's still so much area to press down on the surface of your wrist that it might still be comfortable. Dude. Yeah, I bet. Tell me about it. I don't know why some people are so they're so entitled when they're customers. You know what I mean? Okay, so this now will slide like this. Let's say to the maximum adjustment of 10 millimeters. And ignore the PCB over here. That's sort of the shape that this will take. Also, as a result, you know what? I'm going to do it. I'm going to do it. First thing we're going to do, move this up by 1 millimeter. It's just 1 millimeter, right? What's the worst that can happen? I'm just trying to make this more comfortable. Move this up by 1 millimeter. Move this there to make it match. Okay. Ah, you're the photo expert. Very Peter Parker of you. Love to hear that. That's very cool. Help people a lot when it comes to photo orders, literally IT support. Yeah, I bet that's confusing too because it's hard for a lot of people to understand, I bet, you know, when that technology can go wrong. So that's the surface. And if I get this and that, -1. see what I'm doing here? You see what I'm doing here? 1 millimeter is kind of thin for something like this. But this doesn't have to be 1 millimeter all the way through because the motor is curved. That's kind of an advantage. So I'm just going to move this through to here. And it's going to be a new body. New body. New body. And then we're going to cut this body with that body. Keep the body. The word body is starting to sound very weird in my mouth. Then combine this body with that body. Don't keep the body. And then where will we missing here? I mean, I think this move to 1. Is that what we're missing? Is that what we're missing? So now, see the new version. Now the whole surface of the top of your wrist is going to be pressed down on, and not just the back part. The motor has to be raised up a little bit to make this happen, but nothing crazy. You know? Nothing insane. So I think that's going to work better. Let's see what that shape looks like here. Yeah. Okay. Great. Okay. So that's that part. What are we missing? I think we're missing a limit and a guide. So for instance, if we want this limit to be 10, and I was thinking that in this, these two surfaces here that you see right here are parallel, but I think it's entirely possible that someone may want to adjust this like to here. And in that case, we have a little bit of work to do. So I think what I'm going to do here, because that is kind of a shitty situation for all involved. I'm going to draw a line to cut both of these surfaces. Sort of going through the intersection points. And then exit the sketch. Excuse me. Oh. And then we're going to split these bodies. This one, using this tool. Okay, then we got to reconstitute this one and this one. Shadow's killing me, dude. That's hilarious. I don't know, man. What does have me so thirsty? That's so weird, you know? Okay, so only problem is I don't remember how much I rotated this by. .8 degrees. I'm going to round that to 4, just so I know the number. Okay, didn't seem to cause any catastrophic problems. What that means, we can go back to 4. And this one, back 10. Really interesting. So we have a little tiny struggle here in terms of how to mount this brilliant PCB that I have from PCBWay. I basically just made the smallest one I could with all the components I needed. It'd probably be better for this to be like up here. Even like sticking out a little bit, I think is okay. I don't think that's gonna be like catastrophic for this design. Maybe like here, you know? But then we've got it sticking out over here. So I think let's just, you know, we might have to do some work up here, but let's make sure first that that is adequate for the like adjustment capability. And maybe we can get away with a little bit less. Let's do it that way. So I think move this one first 10. Dude. That's not bad. That's not bad at all. Is my printer done? Okay, good. We have 43 minutes. this down 10. He really said, man, what's got you so thirsty? So that's pretty good. You know? This is kind of sticking out, though. What can I get away with from this vantage point? This looks like it will fit better, except for like the way that it's kind of poking out a bit. It sucks that it's not the same like perfect circle, you know? I did not design this PCB perfectly. But I did a really good job, I promise. I mean, this is okay. What's gonna suck about this is this like nice smooth surface is gonna be a little bit interrupted. But it's probably not gonna be that big of a deal. What's going on up here? Although, wait, think, Mark. Okay. What also sucks is that the LED is now hidden behind another part. But maybe it doesn't have to be. Oh. Let's see here. Doesn't have to be. Could be a little opening there. I'm not going to make a space for the PCB here, but I am going to make it the shape in which the PCB can fit, if that makes sense. So the first thing to do is to, I think, laterally move this PCB to a place like here. So that's sticking out there. But don't forget, it's not that big of a deal. I think 3 is a magic number. Yeah. Oh. All right. The PCB is pretty snug. Yeah. I think any way you look at it, everything about it is pretty snug. So now we have a situation where, so keep in mind, the PCB is not in this current formation interfering with this other part. So I'm going to erase that, and we're just looking. Let's just isolate this, and we'll just work on this part. Okay. Remove that. And so we're just looking here how to get this PCB to fit properly in this part. And I think what we're going to do is keep it simple, stupid. We're just going to take this shape, Fusion 360 would respond to me. That would be quite nice. It would be nice if Fusion 360 responded to me. What happened to my camera? There it is. Okay. What the fuck? What circle am I looking at here? This one and this one. Pretty tight. Welcome, Dino Cuber. Join us. I need to project some shapes. Although, remember, you are not building space for the PCB. You are just making the shape more accommodating to a PCB type shape. I'm conflicted. Okay, we're going to do that. We're going to do different arc. I'm designing the Web 3. That's what I'm working on here. Going back to basics, but also learning, essentially just like taking everything that I've learned over the past year and change about designing this device and then applying it to said device. Wait, that kind of sucks. Hold on. Hold on. Get rid of that. This really should be coincident. There. That. There. And all this crap. Tangent arc. Hey, I'm on the 610's TV. Let's go. That's pretty sick. I'm honored. So that's tangent, but they also need to make them concentric. And that one and that one. And as for this one, new tangent arc from here to here. Here to here. That's probably good. Like, that's probably good. Let's go covering this PCB here. Does that even make any sense? I'm gonna go with yes. New body. What we're gonna do is we're gonna pretend this was the plan all along and never have anybody know what this looked like before to hide the fact that I made an oversight on the size of the PCB. But then the problem is we gotta make it look natural. So hopefully it looks natural in the next couple scenes. It might not. It might not. Okay, then what I'm going to do, combine. This already looks like a little like shit. What happened here? No, really, what happened here? I thought this was... Did I miss something? Oh, I just forgot to extrude part of it. Here. Okay. I had a pretty sizable break in the middle of the day. So that's why I haven't gotten as much done as you might expect for someone CADing the entire day, where I did some parkour. Go check my Insta story. I made a pretty big jump today. That was kind of scary. But, you know, you just turn your brain off. And that's that. Did I keep the tool? No, I didn't. Oh. Forgot about this one. Okay. Select that one too. And that one. Hello. This tool, that tool, and that tool. All together. Wait. Okay. Target, this one. Tool, this one. And that one. Whoa, bro. What has happened? Okay. Target. Tool. Tool. Done. Am I tripping? What the heck is going on? Okay. Accomplished a few things here. I don't like this. We got to make it look natural, remember? So what that means, auto leveling touch arrived today. Ooh, is it the BL touch? I have such fond memories of BL touch calibration throughout my early years of grad school. I was like, it's like I was working with the BL touch every goddamn day. And it would get so sticky, and then it would break and have to be replaced, and we had to put a cover on it, and then we always had to place the cover on the BL Touch before it started printing, because it was printing sticky material. Okay, and once again, this is not looking very natural. So we got to fix that. Got to fix that big time. BL Touch clone. Amazing. Yeah, those are cool. Although, I'm like, none of the printers that I have now use them, but I kind of remember them being pretty standard. Do you think that's going away? I mean, you obviously just got one. Okay, I see what's going on here. I'm going to need to do a tangent line. Like, I think that the printer I have now uses intrinsic force sensing on the stepper motors. No. I'm dumb. Sorry. It has a load cell. That's true. The Prusa Mark IV has a load cell. It's extremely. Did I do this right? What is happening here? Has a load cell. Whoa. What is this geometry? What are we doing here? What are we doing here? Okay. Okay, I kind of get it. Only thing I can presume here is that we need an arc to go from, what am I doing? Just to fill it. Gosh. No sketch. No sketch today. Oh. We're getting some buffering infusion. Undo. Oh my god. Why do I even bother? Bing bong, bing bong, bing, diddly ding ding. Bing bong, bing bong, bing. Korky Buchek. I like very much a Korky Buchek. Okay. We are finishing this sketch, going back to before it was ever created. Deleting it. And thinking critically about our life choices. So we have a few issues here. I guess maybe I'll go for the first issue first. Start at the very beginning. A very good place to start. When we read, we begin with ABC. Sir, sir. Okay. 1, 2 there. Okay, fills that hole. I mean, so the farthest I expect. I don't even know, where are we? We are downward, I guess. We are down here. I'm thinking, remembering how we wanted this to be -4, which means that we now split this body with this body, keep the body, okay, and 10 millimeters, that looks like trash, doesn't it? I don't hate it, but it's just like, why? Like, there has to be a simpler shape here, you know? What am I missing? I'm missing something so obvious. If we get the arc. Okay, we'll just make a 3-point arc between that edge and that circle. Have it be tangent to that, and let's make it tangent to that. Failed to solve. Why? Why failed to solve? Do we need 2 arcs? I guess that's what that would mean. We need an arc and a line. Is what that would mean, right? Okay, line, boom, arc, oh, okay, and then this and this, tangent. Sure. Sure. That's probably the greatest good I'm ever going to get. It's a little bit of a sharp turn. It might not be a big deal. Then, yes, I'm sorry. I'll just wait for you. I'll just wait for you, Fusion 360. No problem whatsoever. I'll just wait for you. And play with my Spider-Man Pez dispenser. Which is the coolest thing ever. I want to put some Pez in it. That's what I want. Okay, so what we have up here this shape is very not natural. So I'm just gonna real quick, real quick, once the buffering is complete, of course. Select that line that I just made and delete it. And then once I've selected that line that I just made and delete it, like this, I'm going to draw a new line. And that line is going to be a tangent to this circle. And once the buffering is complete, now I can draw a new arc that is tangent to, come on. There we go. It's like, I think we got to quit because every time I draw something, it's like, hold on, let me think about this. I love the idea that CAD software, like personifying CAD software, is a very unhealthy thing to do because it's so easy to get yourself thinking that this thing is out to get you with how much it crashes. Okay, we have done nothing except make this a little better. And I'm going to get this chamfer here. One. Whoa. We're not doing a two distance chamfer here. We're doing an equal distance chamfer. Okay. Okay. Now what I want to do, take this, cut it with this, keep tools. Then we move this 4 degrees, rather, plus 6, 7. And we cut again. The other thing I want to point out is that this is now interfering over here, which of course is a problem that I have had many, many times. How do we solve that? Great question. How do we solve that? Great question. Great question. But don't think too much about it We got 12 minutes left. Okay, we're certainly not going to make 12 minutes from now. But let me see what kind of magic I can work. I haven't even done any ratcheting stuff. Okay, let's move this back down. -6, 7. And let's move this up. Not those two. This one up to its neutral position. 10 millimeters. Okay. All right, so we're back to the way that this is supposed to look. Nice, very good, very nice. We have a problem. Select these two here. Maybe just this one. Let's not focus on this one. We'll just focus here. And we're going to set the pivot to, oh, for fuck's sake. We're going to set the pivot to here. And I'm going to rotate the pivot between here and here. Great. Oh shit, I pressed the enter button. That didn't do anything. And we're buffering. And we're buffering, and we're buffering, and we're buffering. Fusion 360, I think, needs to take a nap. And maybe on some level, I do too. After 160 push-ups and 20 dips, I think that I deserve it. Okay. I do want to see, though, real quick. I want to see how this interferes with that other part. Gonna measure here and here. Negatify that. Angle. Save. Okay, clearly I've done something wrong. Son of a, okay. Who would do such a thing to you? One of my best students, that's who. I wish I could have done something like that to my PhD advisor. He would have been humiliated. My goodness. No. We gotta set the pivot. set the pivot to this point, rotate the pivot. We got to measure an angle, measure between flat, slanted. Okay, now I feel like we have it. Shit. Save that pivot. Because now, if we rotate this -4, oh, come on. You don't recall your, are we serious? Okay. Okay. Select this. Set the pivot. No, not that pivot. Set the pivot. Set the pivot. Done. Then, no wait. Set the pivot. Rotate the pivot. Measure the angle between here and here. You got the pivot. So if we go -10, sorry, -10, and then we go -4. Are we? I think we're matching up, right? We should be. I'm pretty sure we are. All right. So now, I mean, see, like that's obviously not interfering with anything because it's way lower. But I think the problem will come when we go way higher. So we bring this back to 0. Bring this back 10. And we go over here. Okay, and so this is an issue, first of all. There's interference there. There's also, there's not interference there, of course. 6, 7. Okay, now I've completely lost the... Think. We got to think here. We don't want this to interfere. It's interfering right now. We want it to still rotate. We want it to still rotate. Don't we? My brain is not braining. Here's what I'm going to do. Can I get this shape? Okay, offset this shape by like 5 millimeters. Ballsy, I know. You know what? Strike that. We're going to draw a thing. We're going to draw a thing. Okay, where's the pivot? We're going to make it look nice, right? Just make it look nice. That's all that matters. Here's the circle. And we're going to have a tangent line to the circle. That's how we make it look like this whole thing was on purpose. And then That's it. No. And then, okay, we gotta wait for the buffering. Gotta wait for the buffering. I love buffering, yes I do, so get me a big old bowl. Rise and shine, it's buffering time. Okay. That there, make this parallel. And then all we need is adequate clearance. So this is going to slide. Now, we know that. But then as this circle moves down 10 millimeters, this is the geometric solution here to my problem. This is what? Why is this perpendicular to something? This and that are parallel, which means this circle, right? Right? Yes. Which means this circle, whatever it is going to be over here. And we also know 6, 7 is the number of degrees from here to here. These need to be coincident. Okay, so that line is going to end up over here after rotating. And that's going to be at the bottom. I wonder. If I take this, and 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 I copy them, and I paste them, and I see where those are going to be in relation to the other ones after rotating 67 degrees in relation to it. Yes and no. It's going to take up more space. So it's going to be more overlap. Okay. So then that's all here. Okay. And then these ones I grab and translate those back to where they would be in the original translational position. That's translation along this line. It's kind of hard to tell. But yeah, -10. Okay, and from this, I then know that these circles have to be like this big. Yada, yada, yada. I can't believe I just did that. Okay, that is geometry at its finest. What do you mean, finished? Did I finish the sketch? I didn't finish the sketch. I didn't finish the sketch. We're buffering again. We're buffering again on Fusion 360, which, as you know, is actually one of my favorite things when Fusion 360 buffers. It's actually like, it's like heaven on earth to me. Okay. I hate to cut out so much material, but it's kind of necessary. And it's going to be okay, I promise. Great. Okay, now we test this. I do want to add some chamfers, though. This is cooking. So the reason why I made that cut there is so that these parts wouldn't interfere in any configuration that they might end up in, which is quite a few because they translate with respect to each other and they also rotate with respect to each other, which has been so annoying to keep track of what is going to interfere with what. So what I'm trying to do here is get the shape at the outset, and then when I make the minutia and the details, that is not as much of a concern. I'm trying to change my strat, in effect. We're also buffering again, which is great. Oh, we're back. Okay, so got this whole thing here. First thing I want to test. Obviously, it's not interfering now. But I think that rotation is pretty straightforward. That there's no interference with just simple rotation. The circuit board can go away for now. No interference with simple rotation. Simply just the door. Open a door. You know what I mean? Great. Then there's the question of translation. Set pivot. Ooh, this is now parallel now too, isn't it? Okay. No interference on this side. And no interference on this side. And now let's do the full 10 there. Because we got rid of the circuit board. We don't need to look at that. So then it's about, in this minimized translation, is there rotation interference? Let's find out. Ooh, wow. That just barely cuts through the noise. 6, 7. Hey, it doesn't interfere. My math was correct. This is big news. Big if true. Um, and it's obviously the minimized configuration. So if we move it up, oh, come on, buddy. You're not that guy, pal. You're not that guy. Yeah, we are going to be just fine. Okay. Let's go. Okay. Let's get rid of the move. Let's go back to neutral position. Go back to neutral position. Good. Great. Wow. We've really done it. 6, 7, like, oh my don't. It's 67 degrees, Shadow. 67 degrees is the key number for the angle at which this door needs to open so that a person's wrist can comfortably slide in. It was 66.8. I rounded up, but it's not my fault. I just wanted a nice round number so that I could remember it. And it's a very memorable number. So this serves a utility, really. Anyway, did I watch the Brand New Day trailer? I think there was one. Was there one that came out in the last like 2 days or so? Because if so, I didn't see that one. But wasn't there one that came out like just like a week or two before that? Because I saw that one, and that was dope as hell. Really excited. And then like the newer one came out, and I'm kind of like, I really don't want this movie to be spoiled for me. You know, because I feel like there's still so much that we don't know about it that like it's going to be hard for me to piece together the plot of the movie before watching it, which is what I want. Like I'm aching for like an authentic Spider-Man movie theater experience, you know. That would just be a dream come true. Okay. So what do we think so far? I think it's still sleeker, even though we've had to add some bumps and stuff. I think it's still sleeker than the old version. What do you guys think? I think that we're coming up with something that looks a lot better, which was quite exciting. It's triggering. You don't like that trend. Man, the Artemis astronauts were doing it, you know? Maybe I'm a little my sense of humor is a little young for my age, maybe. Uh, Usually a big yikes. But I like Seinfeld. That's a damn funny show. And that's for millennials slash Gen Xers, you know? I grew up on Vine. I feel like 6 7 would have killed in Vine. Anyway, yeah, I do think that this is sleeker. It could have came from that George Orwell. You spelled it wrong. It's spelled like this. All right. I feel like I've got a really good start here. Like, really good. Big Brother 1984. That's right. Okay. I think I should probably take a break from this because I'm going to need to deal with this other project here. Oh. So I think before I go, oh, Fusion 360 is buffering again. We're buffering again. Okay, this print is done, so that's good. I can start another one that has the brackets included. There's the brackets included. And this is for my new printer enclosure, by the way, that I am designing based on the very classic Delac enclosure. Was there something else I had to design? There was, wasn't there? Yeah. I don't know what this is. But I'm going to copy this. I'm going to take this one, get this body. So I know a couple things need to be done with this because I have a thicker plate on the top, so I need to make this shorter by about 1/8 of an inch. I'm just basing this off of this, which is maybe not the best idea. So like this, I like that as a cable channel, but I'm gonna need to go minus 1.2, no, minus 0.21, what am I saying? 0.125 inches. And we're gonna cut it here. We don't have to deal with this or this or this. And I'm gonna cut it here. So we don't have to deal with this because that's unnecessary. And we're gonna cut it here. Don't have to deal with that because that's also unnecessary. And I'm just gonna fill in this space. So no one will ever know. No one will ever know what I did. Intersect, bang, 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 bang. No, it was selected already. Go here, call it new body. But we still need this circle. Who knew taking a break is only 30 seconds? No, in fact, the break is going to be much longer because I certainly need it. However, I got sidetracked and I need to get this print going. I'm trying to have like a no downtime on my printer, you know, because there's a lot of things I have to do, including the Charlotte orders. Bang. Sure, whatever. Why is this only 4 millimeters? Is that right? That doesn't seem right to me. This should be 5.65 millimeters. And what am I? Is this supposed to be tapped? No way this is supposed to be tapped, right? I call bullshit on this needing to be tapped. Instead, what I'm going to do, this is a little bit trickier than I thought it would be. I could tap it, and it actually wouldn't be too bad. But I just feel like it doesn't fit with the rest of the design. How much is a Charlotte? Right now it's discounted at $150. But remember, it's just a locomotion platform. But there's two configurations. Let me just pull it up real quick so you guys can see. So it's for hobbyists like you guys, you know, as of right now. So the pre-order period has ended. They are now in production, you could say. So there's a base configuration that has just motors. This is nice for you if you want to add your own battery that will somehow fit in here, or if you maybe sit on top like my earlier prototypes did. This is a very nice, lightweight, very adaptable configuration. See, there's a lot of screw holes here. You can add whatever hardware you want, motor drivers, electronics, controllers, that sort of thing. Then there's the battery configuration, because I found this is actually quite nice. Like, this battery doesn't fit in the original base configuration, but does fit if you organize it like this and put the motors over here instead. So this is sort of like, hey, this also works really well, so I'm just going to also make this one, and I'm including the battery now with this one, because I think this battery works very well. It's like an upregulated single cell LiPo, upregulated to 9 volts. Jury's still out on like how long it lasts, but at the very least, it's like a decent starter battery for this to get your project started. You know, so I'm including that with this. All orders are made to order. Lead time of 30 days. These are the colors that I have, although yesterday 610 wanted purple, and so I decided to buy some purple high strength Polymax filament. That's what all the parts are made out of, high strength PETG. And so I got the purple, and we're gonna make his in purple, even though that's not one of the ones that I currently offer. But once I get the pictures, I'll probably add the color, because I'm interested in people buying different colors so that I can make the different colors and then have pictures of the different colors to actually show people that what it looks like. You know what I mean? And independently, I might make my own colors just for fun, but obviously I don't have the time for that right now. Okay, so I'm gonna draw a rectangle. Maybe to like here. Yeah, that would be cool. Yeah, they're both similarly sized. The battery configuration is slightly longer. It's the only difference. So 106 versus, I think, like 85? 86. 106 versus 86. So basically, you have to add like 10 millimeters on either end, front and back, to accommodate the motor and the batteries being different configurations. Give ChatGPT a body battery. The problem is probably the route to go for one. That would be pretty cool. That would be pretty cool. Pretty freaky, but pretty cool. It would also be cool to like showcase people's Charlotte projects on the website as well. You know, if people are, I feel like that's sort of a permission thing, because it's kind of then like me using, whatever to advertise. So it would have to be like by permission only. Is this good enough? Probably good enough. Now we have to figure out how big these hexagons are so that we can recreate them. 4.677. Don't listen to me. You're going to get upset. 4.677. And do an inscribed polygon. We'll do 4.8. Sorry, I forgot all my geometry. That's not, we need a circumscribed polygon. No, we need an inscribed polygon. I did a circumscribed polygon. Okay. 4.677. This seems small. Did I measure the right? I measure the right edge. Tiny solar panels. I never tested tiny solar panels with Charlotte. There may be a way to do it. The energy consumption might currently be too high. Nope, that is the right surface. But I think it would definitely be interesting. At the very least, you could do solar panels like with a battery, because Charlotte's obviously not always going to be moving. Sometimes she'll be standing around. Obviously, like I envision for her to be like a reconnaissance, civilian reconnaissance robot in the future. Obviously, I'm not interested in giving more power to the government. um, but yeah, so like like oftentimes she might be standing around, so you can absorb sunlight, charge the battery, and then use the battery to walk around. I think that would be interesting to see if that's like a sustainable solution. Yeah, it would be cool. That's the thing. Like, it's like I've developed Charlotte up until this point, and I will develop her more. For instance, I've been talking for a really long time about a reinforcement learning algorithm that I've been thinking of for a really long time. Um, that's probably what I'm going to do next with Charlotte. And then I can kind of start to figure out her like native controllers and that sort of thing. The stuff that, once Charlotte is a full robotic system, what will be included, And then it's also, keeping it relatively affordable, disposable. I know that, for your typical hobbyist like you guys, like $200 is not like disposable. But if I'm thinking about like a fire department, they they need robots for sensing. Um, Basically just getting sensors places where humans can't go. Am I keeping tools here? I don't want to. Yeah, I am. I'm a fool. And So where Charlotte could be useful there is she could walk into a place with some sensors. Then she doesn't have to come back if she's cheap enough, you know. That there's a real advantage there. I know that I visited the New York Fire Department, and they were talking about how, like, sometimes we need to see what's going on somewhere. We just chuck a drone. Like, we have a drone with sensors. We just throw it in, and we never get it back. It's like one of those little tiny cheap ones. You know, there's just so many ideas to uncover, you know, and it makes me excited. That's what research is all about. It's about evaluating ideas. Yay. That's what I love to do. I love to evaluate ideas. Is this a good idea? Is this a bad idea? Oh, well, I don't think it's a good idea. Oh, well, I don't think it's a bad idea. Blah, 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 blah. -2, 3. No. Okay. I think this will be able to be bridged. So this is our next part to print. Yeah. OpenCV? Is OpenCV cheap? Buggy and cheap. So you're not talking about expenses, I guess. You're talking about OpenCV is an incredibly powerful library, and I've used it with Python, but of course it can be used in many other programming contexts. I think OpenCV is great. Personally, it has all the tools that you could want for your sort of like classical computer vision. Like classical okay, you're talking about quality, yeah. No, it's incredibly powerful if you know what algorithms to use. Like it's hard to talk about quality because OpenCV covers it covers pretty much like all of the classic computer vision algorithms you could want, like edge detection, um, optical flow, you know, standard image transformations, that sort of thing. But it doesn't really encompass, unless you do this manually, which is not a very smart thing to do. The machine learning approaches to machine learning approaches to computer vision, as far as I'm aware. So typically there you would use OpenCV combined with PyTorch to, you know, manipulate the image, get it into a way for a neural network to understand, which is pretty trivial. And then use the neural network that's trained on something, whether it's hand labeled data or a public data set or, you know, whatever. I've used OpenCV to, you know, before I knew how to use PyTorch and machine learning, I like used OpenCV and like basically manually coded a neural network, which was dumb. But I did it anyway. But it was a good exercise. Okay. Great. Let's get this guy going. We're going to need 4 of them. I think we can do 4 at once. Perfect. We don't want any support. I think they can bridge this. A radio probably wouldn't work. And maybe a feature that if found by someone lost, the charge or on Charlotte can be used to power a tiny flashlight or maybe radio. I don't see why a radio wouldn't work. You mean like from a solar panel? I feel like there's no reason why a radio couldn't work. Like radio signals don't have to have a lot of power. Maybe to travel far they do. But yeah, I don't know much about those signals. What signals require the most power? There's of course also cellular network. Maybe would be better. That's actually one of the things I want to do is connect Charlotte to a cellular network so they can control her from anywhere. That would be really cool. All right, guys. When I upload this file, I'm going to have to end the stream because I've got to go switch out, take the parts off the 3D printer. But thank you guys for tuning in. This has been a very productive discussion, very productive CAD session. I've enjoyed working on Web3 quite a bit. It may feel like you would have to decide whether to use the power on a flashlight or radio. Yeah, that's fair. A flashlight, if you use an LED, unless it's like incredibly bright, won't require an insane amount of power either. But it depends. All right, guys, thanks so much. And thank you so much, Shadow, for the incredible donation and making me exercise an extreme amount. I am always appreciative of both. Both mean a lot to me, and certainly won't go to waste. You know that I have a lot going on, and your support means the world and will make a world of difference to me. So thank you so much. And with that being said, stay safe, stay amazing, and I'll see you guys in a video pretty soon if I don't get back on stream. I kind of want to go back on stream. I like stream. Okay, bye guys.